So the first one, that one shouldn't have been too hard, right? That wasn't bad. First, before we get started on that, and welcome, I haven't seen you yet, so these guys will lie to you, but I'm really nice. Don't believe them. We're very informal. If you have questions, feel free to ask. Don't worry about putting up your hand, just speak right out, okay? Have you received the homework assignment from the last one?
Yes.
She did? Okay. All right, so the first one, that's fairly simple. The second one confuse anybody at all? No? Okay, good.
Yeah, no.
Yeah? No? Third one, well, R10, what's meant by a handshaking protocol? Now, the answers here are not the only answers, and not only are there different answers, but there's different ways to say them. So if it doesn't look like, if what I have there doesn't look like what you have, that's not necessarily a problem. And if you have a different opinion, let me know and we'll talk about it. Having the discussion is more important than getting anything right or wrong. Okay? So this is good? We're good here?
Yeah.
R10, how about R11? R11 makes sense to everybody? No problemo? Another shorter answer might be that the application architectures require connection-oriented sessions. It's a lot fewer words than I used, but it's mainly the same thing. I was trying to be a little bit more explanatory. Did we put the one with the answers in the online classroom too?
No,
Not yet?
not yet. Yeah.
I sent it to you though, right?
Yeah, yeah.
How about R15?
What is it?
Whoa. What the heck? Let me adjust the... Well, I don't know why they did that. Because obviously, I'm plugged in and charging. All right, sorry. Anyway, R15, control information out of band. This is not a critical concept, but remember we talked about last week, Thursday I think it was, multiple ports, multiple sockets being open for sessions between two endpoints, the same endpoints. And the data transfer, the productive work is always considered to be in band. Out of band is anything that is control information or other maintenance type information for the in-band session. It's not, you won't run into it as often, it's not as critical in, what the heck? It's not as critical in FTP as it is in H.323 or voice over IP sessions. Voice over IP sessions have, because of the timing dependencies, because of the lack of resiliency in the transport, because of the fact that it can't tolerate data loss, out-of-band sessions, out-of-band conversations in voice over IP are extremely important. And so you run into, in debugging, for example, looking at out-of-band sessions in voice over IP more often than you will with FTP. FTP is pretty rigorous. It's hard to break FTP anymore. Okay. Guys, start it. All right, so enough about R15. R20. How many people did this? I mean, did you actually look at the head? No, nobody did?
I couldn't run the Wireshark in my
Okay.
MacBook.
What do you use for an email client on your Mac? Whatever the built-in
Gmail.
one is?
Gmail.
Or you're using Gmail from a web interface?
Yeah.
Yeah, you probably can't get at the headers that way. One of the things I use is Outlook. Anybody using any other? Thunderbird's a really popular. In fact, if I didn't have to use Microsoft Office for so much other stuff, I'd use Thunderbird for an email client. Thunderbird is just an excellent client. You need to get into there. Most clients won't show you all the headers because the header information can be huge. And it's obvious from what we have here, right?
Is Thunderbird part of Firefox? Like Mozilla Firefox? Mozilla?
Thunderbird is a Mozilla-based application, yeah. I don't think it's maintained by the same people anymore because that stuff started off with Netscape, right? And Netscape's kind of disappeared, and different groups have taken up the open source maintenance of those, each application. But yeah, if you're looking for forums and that sort of thing, or to turn in bugs on Thunderbird, it's at the Mozilla group. Anyway, you need a client that has to be able to show you all the headers, or you've got to run Wireshark. Why you can't run Wireshark or couldn't get it installed, I'm not sure. Other than I know Wireshark has had problems with OS X. Give him an F for the day. Okay? We're going over the homework assignment and just seeing who has questions on what. Anyway, dumping the headers out of an email client is a complicated endeavor, and so I included them for what I was able to dump, and the next best way to do it is to use Wireshark or some other tracing application. And here's the header from, as a matter of fact, let's give me a sec. And we'll look at that in a text editor. Oh, rats. That's probably on my other machine. As I say, a text editor is easier. We'll make this a bit smaller. Is that too small? It gives us more of the headers. But you'll see up here, this is, the headers are a push down structure, okay? So the latest ones will be toward the top. This is, obviously this is from somebody at an EDU, all right? And it was received from Comcast, and then Comcast sent it on to Google. more Comcast, and then eventually went through Google. See, here's the Mail YH0F41. Here's the intermediate hop. See that? And here's all this other stuff, including there have been extensions to these are captured because I use IMAP as my mail protocol, and I use IMAP for the support it gives to folders and to synchronization, so that I can keep more stuff offline, if you will, but not get out of sync between my client and the server. So there is some IMAP embedded stuff in here, and that's going to be after this. Here, this is actually the email header and the mail client header. Okay, here you see it's being received by my Microsoft Outlook, and it's a multi-part email. It just means that the email is larger than discrete datagram, so it was broken up and then had to be reassembled. Here is the addressing information for email. But the question was, look over them. Is it possible to determine from the header the IP address of the host from which the message was sent? And, shucks. We see embedded a number of different IP addresses, right? So the answer is yes, it is possible. Now, this being the EDU email, or headers for the EDU email. Here are the headers for the Gmail one. Okay? And you'll see they're quite a bit different, but generally they're different because in this case, Stephen is directly on Stephen is using the web interface to the actual Gmail server, so there's not a lot of that intervening stuff in place, right? If it's an EDU site, odds are the EDU site, an education site, a university or whatever, has their own email server, but then their email server is dependent upon, even though it's defined in the DNS records and the MX records, their email server is dependent upon some other higher order server, mail server in the network to forward mail for. Gmail itself generally resides immediately adjacent in the adjacent network to the core, so you won't see a lot of that intervening stuff. And in this case, we don't, here's an email address here. This should be the one from where Stephen sent the email. And then here, in this particular case, is the receiving address. See, here's the Comcast, well, in this case, the Google server that's forwarding it on. And then here's all the associated identification information. Right. So you'll see here, remember talking about MIME? Slide that we put up, MIME set of predefined or standard definitions for different object types for network. So the answer to both is no matter what, yes, we can identify the sending IP address or the IP address from which the sender initiated the email. It's just the headers look a lot different because of the way that the mail servers are connected to the network, right? In this case, the EDU, the Northwestern, is an edge network, and Google at best or at worst is an adjacent network and part of the, it's one step removed from the core, whereas Northwestern's, that NPU, is a couple steps removed from the core network. All right, that was easy. Consider the following string of ASCII characters captured by Wireshark. What is the URL of the document requested by the browser? How many people had a problem with this one? I can't, you know. Version of HTTP, oops, I left a space out there, out of there. Everybody see the version here? Browser having a persistent or non-persistent connection. That's a little tricky.
Is the connection keep alive?
Correct.
So it's persistent?
Correct. Very good. Everybody, or has anybody else ever run into keep alives? Most common to configure keep alives as an end user in Telnet. If you don't configure it in Telnet, then you're at the mercy of the end server to which you're connecting, and all of them have some configured time parameter that defines how long a connection is allowed to be idle before it's taken or torn down. The way to defeat that idle parameter at the far end is to use keep alives. And all keep alive is just one end sending to the other one, in effect, like a ping. It's just a small packet, and all it's intended to do is keep the session up, mimic or pretend to be traffic, so that it's not detected at the far end as an idle session. Okay. What type of browser initiated the message? There. Why is that important? I don't remember if I referred to it in this class or not. Browsers, well, let's step back. Internet standards are defined so that all users who want to communicate with some remote application that they have no control over, that they haven't written, that they have no experience with, have, because of standards, a defined set of rules that they can use, a defined syntax that should guarantee that the far end, if the far end supports the same syntax, in this case, let's say HTTP 1.1, will recognize and will treat in a dependable and an expected fashion. One of the worst offenders of standards usage is Microsoft. And Microsoft's Internet Explorer didn't until the very last version, which is 12 or 13 or whatever the heck it is, with Windows 8.1, Windows 8, didn't support HTTP 5. Okay. Or, excuse me, HTML5. All right? So, this question here, why is the browser type needed? Browser type is needed so if you're writing an intelligent application, you have the ability to configure your syntax that you use, the formatting of the traffic that you use, so that it matches the capabilities of the other end of the session. Okay? Anything else weird or difficult for anybody in here? The IP address of the host on which it's running? That's that'll probably be easier if I look here. Oh, IP address isn't in there. I must not have copied all of the text. Sorry. You could easily get it though by doing a who is or doing a DNS lookup, right? Next one, the text below shows a reply sent from the server in response to the HTTP GET. In the question above, was the server able to successfully find the document or not?
Yes. Yes.
Yes?
Yeah.
All right. When was the document last modified?
18. Yeah, there you go.
That's not real hard. How many bytes are there?
How many bytes? 3,000? Oh, yeah.
Content length? Right. You know, almost 4K. Huge document. Trick question, not a trick question, but you'll notice that down here it says much more document text following here. Assuming that this has been broken up or has been disassembled to be put into datagrams for the transport layer, what size datagrams might they be? Well, anything less than 4K, right? Might be 2K packets, they might be 256 byte packets. I mean, you can't tell. What are the first 5 bytes of the document being returned? Oops, I left one out.
What is that? CMPSCS.
Oh, that's computer master's program. This is out at MIT. It's that guy at UMass. Right, so that's just the acronym that defines the program at the university. All right, did everybody read RFC 5321?
See, I haven't.
How would you find it? Yeah, Google. He answered everything. Google. Not Bing, not Yahoo, Google. It's at IETF.org. Right? That's the standards body, IETF.org. Assuming that the originator of the spam email is malicious and all other hosts are honest, what's the malicious host? Ah. PP33 head. Here's the originator. Sent to computer science at UMass. Going back to your question just a little bit ago, Stephen. Okay, and it goes via Exchange DDD, and then Barmail CS UMass. Oh, you got an intermediate hop at ASUS US. And then here's the firewall. All right. Just another exercise in looking through headers and being able to identify things. Now we get into the good questions. How many people looked at who is? It's a trick question.
Who is?
Who's website?
Hmm?
Whois.com.
Correct. That is one way to get at it. I don't remember if it's .com or .com might be the
.net.
commercial offering. I think there's a whois.org.
The net.
.net.
.net.
Yeah, .net.
And what is it? It's just a portal that gives you access to all the records in the DNS servers. They all get in the process of moving my production machine from one location to another. I had to update the DNS records. Why? Why would I have to update the DNS records? Trendyc.com stayed the same. Why would I have to update the records?
To find the IP.
To allow people to find the IP, correct. But if I'm moving it from one location to another, is the IP going to stay the same? No. No. Remember, the IP address is associated with a physical machine. I'm lying, but you don't care. It's associated with a physical machine. Not only that, but IP addresses, and you should have seen them in going through this exercise, IP addresses are allocated in blocks, right? Large blocks of addresses, or small ones, get allocated to. Google has a huge, actually Google has more than one huge set of IP address blocks. Olivet has a small block of IP addresses. Okay? Trendici had a small block of IP addresses. And they were allocated out of the larger block that the original hosting company had, which was GoDaddy. Right? So you bring up a machine on, let's use an example, AWS. Amazon has this set of, I don't even know anymore, let's say 16, set of 16 blocks of IP addresses. Those 16 blocks may contain a dozen subnets in each one. And each subnet has, if you boil it right down to Class C, each subnet has 255, actually 254, well, okay, to be perfectly accurate, 255 addresses. One of the 255 addresses is going to be a broadcast address, which nobody can get at, so it's 254 uniquely allocatable addresses. So there's all kinds of addresses out there, although IPv6 came out because we were running out of IPv4 addresses. Anyway, if I'm moving it from GoDaddy to somewhere else, I probably got to get, or I will get, a new block of addresses for Trendici, right? Well, where are all the DNS records pointing? They're pointing back at GoDaddy, right? So when I make the move to a new hosting company, I have to update all the DNSs out there. I have to update them with the appropriate records. I think I probably have. Okay, so in doing that, all of those records then, are they going to get updated on one DNS, on multiple DNSs? Now the problem is, can the instructor remember where the records are? Oh, yeah. Okay, Trendici.com. Remember talking about zones? Briefly, we talked about them briefly. The zones define a group of IP addresses. Okay, and here's any of you editors out there, by the way, this Notepad++ is probably the best programmer's editor I've been able to find anywhere. I mean, it's absolutely fantastic. Here's the zone record. This is what needs to be changed. Okay? And there are records within it. What does this look like, by the way? It looks like XML. A little bit. Must be edited before being used on a production DNS server. Okay, so you'll notice you go through, especially open source stuff, that most of the headers stay in there, and you know there are all these templates that are provided, but those of us who do programming and stuff, we never bother with the headers. That's just a pain in the butt. So what we do is we just change all the rest of the stuff and leave the headers the same. So here's the SOA record, service-oriented architecture. Okay. Here's the domain controller. This is for the new hosting company, the new location. Okay.
So it's kind of like a alias.
Which?
Oh no.
I mean, fundamentally, every URL is an alias, yes. Because again, we don't deal with URLs or text strings in resolving addressing, we deal with numbers, right? So, yes to that, but
Oh yeah.
now, and then here's the synchronized, yeah. Shower head. Oops, I mean, yeah, I screwed it up. Let me match it.